In this video, I will be going over a few problems regarding estimation of population proportion. But before I start, I want to do just one example that captures the entire idea of what we're doing in here. So suppose you have a random sample of 60 people, and it has to be a simple random sample, so that it's not like clustered in one place or only from one age group or something. You have to make sure that you're getting a sample that's well represented from the entire population. And if you have such a people and you found out that 40 people regularly drink coffee, then from that, what can we say about the percentage of all the people in New York City who are coffee drinkers? And the naive way of answering this would be just say, oh, well, 40 out of 60 people drank coffee, so about 67% drink coffee. Yeah. And this would be called a point estimate because, well, that's the best you can do. You only have 40 people out of 60, so what can you do? You just take that proportion and say report it as 67%. But as soon as you say that, you know that it's not going to be the real value. If you actually were able to uh, ask everybody that lives in New York City whether they are regular coffee drinkers or not, well, it's going to take a lot of time and money. It's impossible, but theoretically, if you did, you're going to get some value, the proportion of the population. And our 67 will only be an approximation of that value, right? And because it's an approximation, it comes with some error. So the next question you naturally have is how much could the error be? And there's this nice formula called the margin of error formula. And it tells you how much error this statement would have. Like if you say 67%, but what's like the maximum error? Okay. So we have this formula, but even if you have a formula, if you don't know what these letters mean, it's meaningless, right? So let's try to understand each one of them. E itself is the error. P hat is this naive point estimate, just taking the simple division. And Q hat is 1 minus this value. N is the sample size as 60. I guess Z alpha over 2 is the hardest one to find. I think some people think alpha over 2 is multiplied. No, it's not. Like, alpha over 2 doesn't directly get used in the computation. This Z alpha over 2 is more like a function of alpha. So first you have to figure out what alpha is by this formula 1 minus confidence level. And, this question is just introduced to give you some idea of what we're trying to do. So I didn't make it like a statistics question, but if you actually saw something similar in a statistics class as an exam problem, then usually what they would say would be find the margin of error or find the confidence interval with 96% confidence level or 99% confidence level, some confidence level. Or they might just give you the significance level like 0.05 significance level, or sometimes they would say like 5% 5% significance level. So whatever it is, you first have to find the value of alpha, the significance level, or sometimes they say alpha level, and you plug it into this function where this inverse norm is a function you can find on your TI-84 calculator. Okay, so and it's the sample size. By the way, before I continue doing this calculation, this calculation is only valid if your NP is 10 or greater and NQ is 10 or greater. And if either one of these are less than 10, then it becomes less accurate, and you might get a value that's a little off. Some books they say, well, you can have like at least 5. That's still possible. But I think 10 would be like the safest case. Okay, if you have NP hat greater or equal to 10 and NQ hat greater or equal to 10, then this approximation is valid. All right, so back to what we were doing. So let's say we have a 0.05 significance level that was given in the question, and we did this computation. I'm going to show you how to use this inverse norm, the calculator, in other questions later. So I'll just assume that we did that. Okay, so I'm skipping this one for now. But let's say we got this value, and now we can plug in all the values. This says 0.6667. 1 minus 0.6667 will be 0.3333. And then n is the sample size, which is 60. So if you compute this, you get 0.1193, which is like 11.93%, or about 12%. So let's see, 67% minus 12%, that's like 55%. And 12% plus 67 would be 79%. So with this much error, what you can say is that, the true proportion of people living in New York City that are coffee drinkers is probably between 55% to 79%. And that sounds really wide, right? It's less impressive than saying a definite statement like, 67 people, that 67% of the New Yorkers drink coffee. But this actually gives you a better idea of how powerful your result is. So, and another thing is that because n is in the denominator, if your n size, the sample size is bigger, the error decreases. So, suppose you had like 6,000 people, and you got 4,000 people as regular coffee drinkers, then this would be a lot smaller, and then your result can be used to give a better idea of how accurate this would be. Okay, and that's what companies do when they do polls. They spend a lot of money trying to get better quality samples and more samples. Okay, but anyways, so this is pretty much it. So when you write your answer, you have to say that 66.67% plus or minus 11.93% of New Yorkers are regular coffee drinkers. And what this means is if you add and subtract, you get 0.7860, and subtract, you get 0.5474. And you can say that the p without the hat, this p without the hat is the true proportion in the entire population. And this p would be some value between 0.5474 to 0.7860. So that's what p is. Okay, so that's what this result is. So when you have such a result, you should be able to convert it to an interval notation like this one. It's not interval, like confidence interval like this one. Okay, so I guess we're ready to do some questions. Now let's go to the very first question. Find the critical value z alpha over 2 that corresponds to a 91% confidence level. Well, confidence level is 0.91, and then alpha is 1 minus the confidence level, so you put 0.91. 1 minus 0.91 will be 0.09, right? And then for z alpha over 2, it would be inverse norm. Inverse norm of 1 minus alpha, which is 0.09 over 2. So let's try that. Here's a TI-84. Turn it on, clear, second vars. You take the inverse norm and you do 1 minus 0.09 divided by 2, and then you keep entering and then paste it, and you get 1.6953. 1.6954. 1.6954. Okay, so that's how you solve this question. Next question. Express the confidence interval p between 0.66 to 0.8 in the form of p hat plus minus e. Okay, so in the very first example, I showed you I said if you do the calculation, you usually get your answer in this form, and you should be able to convert it to this interval form. And here they're asking you to do the opposite. So there's no formula for that, but what you can do is you can kind of have an idea of what's happening. See, this confidence interval has this this property. It's obtained by having p hat, our point estimate, and the maximum possible value is point estimate plus the error, is right here, and or not maximum possible. Possible values can even be beyond this, because this is really under some confidence, right? So, but for some given confidence level, you have this upper critical level, and that's defined as p hat plus e, and the lower critical level would be p hat minus e, right? And because this is the structure of this interval, and you're saying that this is 0.66, whereas this is 0.8, you can kind of see the p hat is like in the midpoint of the two extreme values, these two values. So to get the p hat, what you need to do is you just have to take the average of the two to get the midpoint. So I know that p hat is 0.73, and now you have 0.73, you can just subtract the critical upper critical level minus the 0.73, and you get the value of 0.07, right, if you subtract. And by the way, you can also do the other way. You can also do 0.73 minus 0.66. You'll still get the 0.07. And once you have the p hat value and the e value, now you can state your answer as the answer is 0.73 plus or minus 0.07. Next question. The following confidence interval is obtained for a population proportion of p 0.505, 0.545. Use the confidence interval limits to find the point estimate p hat. And the answer would be again, p hat is the average, right? So you add these two and divide by 2, and if you do that, the answer is 0.525. Next question. Assume that a sample is used to estimate a population proportion p. Find the margin of error e that corresponds to the given statistics and confidence level. Round the margin of error to 4 decimal places. Okay, so you have this sample size 6,500, and let's say this is again like coffee drinkers. You found 1,950 people are coffee drinkers, and you want to find the margin of error when you choose the 99% confidence level. Okay, so you should first start by estimating the p hat, which would be 1950 divided by 6500 equals to 0.3. So you know that like 30% of the entire populations are coffee drinkers, or whatever. It doesn't really say what they're investigating. Could be like the popularity of a politician, which is like the most frequent times you hear about it in the news. But anyways, you got this 0.3 as your point estimate. So the true population proportion p would be some value close to this one, but there will be some error. So there will be some margin of error. We have to figure out what that margin of error is. Okay, so recall that for the margin of error formula, we had this formula right here. It required p hat, q hat, n we already have, and you need the critical value z off over 2, right? So that's why I'm trying to calculate q hat as 1 minus p hat. That's the definition of q hat, and that gives you 0.7. And then for the alpha level, or the significance level, is defined as 1 minus the confidence level. 99% converts to the number 0.99, so you do 1 minus 0.99 and you get 0.01. And then you again use this inverse norm of 1 minus 0.01 over 2, and I got this number. Let me just check that again. So you have second vars, you go there, and then you're getting the inverse norm to find the critical value. Oh, I forgot to change it, sorry. I have to change this to 0.01, and then I see that's 2.5758, so if you round it, you get 2.576. Okay, so we have this value. Now just plug it into the formula for the margin of error, and you use this, you just punch this into the calculator, and you're going to get 0.0146. And you do it like this. You just put 2.576 times, and then second square root, and then you have 0.3 times 0.7 times, not times, sorry, should be, let's delete this, and then divide it by 6,500. That's the sample size, and if you enter, and you do get this value, right? Okay, so that's how I got this value, and that will be the answer to this question. Here's a similar question. What is the confidence interval? You're given this n as 125 sample size, and the x is 72, so the point estimate will be 72 over 125, and then you have to gradually find the margin of error and then figure out the confidence interval. Alright, so let's begin by first calculating p hat, which is 72 divided by 125. Using a calculator, you get 0.576. Again, you compute the q hat by 1 minus 0.576. Again, with the calculator, you get 0.424. You already have the n. Now you need the critical value. So alpha is 1 minus 0.90, which is 0.10. So you have to calculate z alpha over 2 by doing inverse norm of 1 minus this. And I think we've done enough examples, so you know how to come up with this number, right? So let's say we have this number. Now what? We plug everything into the calculator, and we get 0.0727. That's our margin of error. This is our point estimate. So the actual value is this point estimate plus or minus this margin of error. So you get the following. But this is not yet the confidence interval. You actually have to do the addition and subtraction using a calculator to find the two values. This is the lower critical limit, and this is the upper critical limit. Okay, and then intervals are written as open intervals are written as two numbers. The smaller number should always appear first, and then the big number. So that's our confidence interval. Or sometimes you may have to write it in this form. Okay, so you have 22 randomly picked people, and they rented or owned, and there's 9, so I guess the point estimate will be just 9 divided by 22, so that's the answer. Oh, actually, no. We should read the question closely. 9 people said they rented, and it's about point estimate of the proportion of homeowners. So since 9 people rented, it must be 22 minus 9, 13 people owning their home. So the actual answer should be 13 divided by 22, which is 0.5909. So that's the correct answer. Okay, now given the data to find, use the given data to find the minimum sample size required to estimate the population proportion. So here the question is reversed. Usually you're given all the information and you're trying to find the margin of error, but sometimes you want a target margin of error. You want to have your margin of error less than 0.05 or 5%. 5 percentage points. And to do that, your sample size has to be pretty big, right? The smaller your margin of error is, you need a bigger sample size. But how large should it be? And often this is what company has to decide before they start doing anything, because if you have a political poll or something of that sort, you usually go out to do surveys, but a lot of people refuse to do the surveys because they're too busy. So you may have to like contact the same person 10 times, or you may have to just reach out to 10,000 people just to get like maybe 500 samples. And these things cost money. I heard like something like it takes about $60 per person to get a survey out of them. So multiply that by 1,000, which is like the usual size of the study. So that's like $60,000 for each research. That's a lot of money, right? So having some idea of how large your sample size should be is quite an important question. All right, so let's take this formula. The margin of error is this formula. And remember, all of the other values will be given to us, but n is not given. So you're trying to really solve this for n. And although you can just plug everything in first, and then you solve for n, because the numbers will be decimals, it's hard to solve it after plugging in. So it's a better idea if you can just solve this one before you plug in numbers. So let's do that. First, what you want to do is you want to multiply the square root of n both sides, so that you have e times square root of n equals to z off over 2 square root of p hat q hat. And then you want to divide by e both sides, so that you've isolated square root of n, and ultimately you have to get rid of the square root as well. So you square both sides, and so you get square of the critical value z, and then you get square of the e, but then square root gets cancelled by the square, so you just get p hat q hat. So this is the formula for the sample size. Now let's plug in everything we need. The z off over 2, however, has to be calculated, but we did do it a few questions ago, right? When the confidence level is given as 99%, our critical value was 2.576, right? So we'll just quote that one without having to do it again. And then because our e is given as 0.05, and the estimate of p is 0.15, so that will be our p hat. That's our estimate of the value. And then computing q hat as 1 minus p hat, you get 0.85. Plug everything to the right side, and you will get some value, which is 338.42. And here's actually another important point. When you get an answer for estimating the population proportion, you can't have like 0.42 people. That's impossible. So every time you get a value, you always round up. You don't go to the nearest integer, but you round up, because you want the error to be less or equal to 0.05. If you go with 338, your error is actually slightly bigger than this 0.05, so you don't want that. Okay, so always when you're trying to estimate the minimum sample size, you always round up. So the answer to this question would be 339. Now let's go to the next question. This one is very similar to the previous one, except that p hat and q hat are unknown. So you have this formula that we obtained in the previous question, but we don't know what p hat and q hat are. If that happens, then just go with 50-50, which means p hat will be 0.5 and q hat will also be 0.5. And because, I mean, if you don't know what's going on, 50-50 is like the most reasonable choice, isn't it? But it also has the effect that it makes this value as large as possible, and it's better to have more samples than less, so that's why people use half and half. Okay, so we're going to use half and half. Z square alpha over 2, well, we'll have to again find the significance level as 1 minus 0.96, which is 0.04, and then again you do the inverse norm, and you put 0.04 because that's our significance level, and then divide by 2, paste that, you get 2.0537. So that's the value of the critical value, 2.0537. And then E is also given to us, it's 0.015. So just plug in everything to this formula now. As you can see, I'm using 50-50. And then you compute this, and you end up with 4686.31, which means you need at least 4,687 samples. Yeah, that's actually quite big. You'll need a lot of money to get that much sample. Okay, the last question of this video, let's try this. A survey of 865 voters in one state reveals that 408 favor approval of an issue before the legislature. Construct the 95% confidence interval for the true proportion of all voters in the state who favor approval. Okay, so for this you should start out by finding the point estimate. Just divide 408 by 865, you get some proportion. And of course, to get the margin of error, you need a Q hat, so you do 1 minus 0.4717, we got this value. Then the next value we need is the critical value. Since we're doing 95%, the alpha level, or the significance level, will be 1 minus 0.95, so it's 0.05. And you again use the calculator to find 1.96 as the critical value. So now we can plug it into the formula for the margin of error. We have everything we need. So 1.96 is the critical value. These are P hat and Q hat divided by the sample size 865, and we get the value 0.0333. All right. Now you do P hat plus or minus E, so I subtracted this value from the P hat, and I got the two values, and these will be the lower critical limit and the upper critical limit of the confidence interval with 95% confidence. Okay, so that will be your answer, and that's it.